let us now study about the cyclotron. The cyclotron was a device which is used to accelerate particles. Okay, we can accelerate positive ions to a very high energies and very high speeds to cause nuclear reactions. It was invented by Lawrence and Livingston in 1934. Okay, let's see what is the principle there. Okay, the principle is when a charged particle moves perpendicular to the magnetic field, it experiences a magnetic Lorentz force. Okay, so let's now see what are the parts of this. Then we'll understand the principle there. Okay, so actually it has two D's there. Okay, these are called as D's there. It's shaped like D. Okay, that's why. Then if you see the D's here, they are hollow inside. Okay, it's a three-dimensional picture here. Now you can see this. It's hollow inside. You see like this way. It's like a tiffin box only. Okay, if you cut open a tiffin box, how would it look? Like the way. Now next is these two D's are kept between the two poles of a magnet here, electromagnet. Okay, this becomes the north pole, and this becomes the south pole. Okay, and the whole thing is kept in a vacuum chamber. Okay, now we have drawn only the D's there. Okay, these two D's are connected to a high frequency accelerating voltage. That means oscillator. Okay, like how we have the AC plug point nodes, but it will be having more frequency, high frequency. Now what happens is we're going to keep a say proton here. Okay, let's keep a proton here at this point. This is a source there, source of protons or alpha particles. Okay, so now what happens is let's now take this is a positive charge here. Okay, proton. Okay, now first imagine this D becomes negative and this D becomes positive. Okay, and there's a magnetic field also there. Okay, magnetic field is going into the board. Okay, so it's given by this way, north to south. Now, so due to the magnetic field, what happens is the particle from here in the middle, okay, it will actually curve there. Okay, due to the Lorentz force, it will start curving. As it comes here, what happens is it will be attracted by the negative charge. So it will be attracted, it will go more faster there. Then as it comes here, okay, it will come here, then there will be no attractive force, but due to inertia it will go this side. Okay, and more than that, what happens is that time it will reverse there. Okay, this is an oscillator now. So this portion will become negative and this portion will become positive. Okay, so because it's negative, it will attract the positive charge from here and it will go this side. Okay, and then what happens again, it will turn due to the Lorentz force, it will come here. Again this will become negative and it will be attracted. Like this way it will make many rotations there. Okay, and then after getting a high energy, it will come out here. Okay, there is a deflector plate. Okay, this deflector plate also has a positive charge. It will deflect this proton like this way to a target there. There will be a target here. Okay, and this target will create a nuclear reaction. It will cause nuclear reactions there on the target. So this is how it works. Now let us go to the equations part here. We must get an equation for the radius of this orbit here. Okay, what will be the radius of this orbit here, and what's the frequency and what's the time period. Okay, so let's see this now. Now you see, as it turns in this part, okay, as it turns here, it expends a force towards center. That's force called a centripetal force. Okay, the centripetal force given by the Lorentz force there. Okay, so Lorentz force makes it to turn. So centripetal force, the centripetal force is what it is, the Lorentz force there. Centripetal force formula is mv square by r. I have written r differently to show difference from v here. Okay. Next is Lorentz force formula is qvb. Okay, so this is a formula for Lorentz force. You must find the radius there. So what do you cross multiply, interchange here? So get here mv square by qvb is equal to r. Okay, now v and the square will cancel. Okay, now remaining equation right on top. I'll erase this and write on top. Okay, let's write this on top now. So radius r is equal to mv divided by qb. Now what happens is we'll take these terms here together. Okay, mass is a constant, charge is a constant, and magnetic field is a constant. So you can say the radius is proportional to the velocity. That means as it gets having higher velocities, what happens? The radius also will increase. Okay, so as it goes faster, radius will increase there. That we know. Okay, next we'll see. We know that we already learned that. Okay, when a particle goes in a magnetic field, it experiences a force, Lorentz force we learned. Okay, and then we also learned the frequency also we learned. Okay, so we know that the frequency of oscillation, okay, frequency of oscillation comes to be qb by 2 pi m. Okay, this we already derived. Okay. Next, what you must find the time period here. Okay. So time period t is equal to, you must reverse this now. Okay, 1 by f. Okay. So time period is 1 by f. So when you do that, what happens? Time is equal to 2 pi m divided by qb. Okay. So this equation will get. Next, we'll see what is the kinetic energy here. Okay. Right here. So kinetic energy formula is half into m into v square. Okay. So now I'll take this equation, and from this equation we get what is meant by v. Okay. So from this equation, that is r is equal to mv divided by qb, we must get v. Okay. So what do? Cross multiply qb upwards and bring this m downwards. So we get here r, or we'll write here qbr, or this r will write, divided by m is equal to v. Okay, rearrange. V is equal to qbr by m. Okay, so let us name some equations here. This equation is 1. Okay, this one will write as 2. This is equation 3, and this is equation number 4. Okay, so substitute v in equation 4. Substitute v in equation 4. So in substitute, what happens? Substitute here. So get here kinetic energy. This is actually kinetic energy, Ke. Okay, that's equal to half into m into this v square, that will be qbr divided by m the whole square. Okay, so what happens is we get here half into m into q square b square r square divided by m square. So m and the square will cancel. Okay, I'll write the remaining step here. So let me continue writing this side. Kinetic energy, write the side. So kinetic energy formula comes to be half, then q square b square, and then small r square divided by m. Okay, so this is the equation for the kinetic energy. Let me get now. Okay, so now we got this equation. This is r square. Okay, it's clear. So now let's see what are the limitations of the cyclotron. I'll write down here. So now let's see the limitations of the cyclotron. First one is the speed of the ion is limited. Okay, why speed is limited is we can make a small size only. But now we have large hadron collider. Okay, it's a very big thing. It's in Geneva. It's around 4.2 kilometers. It's a type of cyclotron only. Okay, so there are many other devices that are coming there, but speed will be limited only. We can't give it to very high speeds there. Then next one, the electron cannot be accelerated. Okay, so there's an electron. If you keep an electron, it won't rotate properly. Why? Because due to relativistic effects. Okay, so there's something called as relativity. It was given by Einstein. So due to that, what happens is the electrons cannot be accelerated properly. Next, the third one is uncharged particles cannot be accelerated. Uncharged particle means what? A particle which has no charge. Example, neutron. Neutron has no charge. So if you keep a neutron here, it won't be attracted by the plates there or the d there. It won't revolve so properly. Okay, so neutrons cannot be accelerated. Neutrons or other uncharged particles cannot be accelerated. But let's see what the use is there. To accelerate protons, deuterons, alpha particles, and to cause nuclear reactions. So you can accelerate the protons. Protons have positive charge. Deuterons have positive charge. Deuterium is a type of hydrogen. Okay, alpha particles, helium nuclei. So they are all positive particles. They can be accelerated and they will cause the nuclear reactions with the help of this. So we can also say it's a particle accelerator also. So cyclotron is a particle accelerator. Yes, thank you for watching.